Trigonometry. Yes. Anybody remember what God meant when you learned about polygons?
No.
Sides.
Sides. It actually means sides. Originally it meant angles, but it actually changed historically at some point to mean sides. What do you think metry refers to? Measurement. Perfect. 3 sides measure. Trigonometry means 3 sides measure. So we're talking about measurements involving things with 3 sides. What has 3 sides?
A triangle.
A triangle.
So we're going to spend a week measuring triangles.
We're going to be measuring very abstract triangles. We're not actually going to pull out a protractor or a ruler at all.
Why not?
Because it's easy.
Because that would be too easy, basically.
Fun,
Okay, now, we're going to review.
you should let us do something fun for once.
Nope. We're going to review 3 things, and we're going to learn 3 new things. Sort of new things. You'll see in a minute. Given a triangle, okay? Given a right triangle. And I'm going to write up here only in right triangles. Luckily, right triangles are very useful. But keep in mind, a good trick question anywhere on this is if I throw you a triangle that does not have one angle of 90 degrees, then everything I'm telling you is no longer true. In a triangle, we have an angle, and I'm going to call this angle theta. Have you guys seen the theta symbol before?
Oh, my sister's a part of that sorority.
Okay, well, great.
So just stay away from everyone, because everyone
Right.
sneezes at least once.
Okay, has anyone, guys, hey, has anyone here ever seen
No,
theta?
No, it's swine flu season.
Okay, besides sorts, okay.
It's on my
Theta,
calculator.
it's on your calculator. Theta is a Greek letter, okay, and it's a Greek letter that is used for angles the way x is used for numbers. So it's an unknown angle. Theta is an unknown angle. Now, there is something called the sine of theta, which is written as sin, and then the theta. Now, before we get to that, I'm going to label this triangle sides in relationship to theta. One side of a triangle always has the same name. Any idea what that is?
The hypotenuse.
The hypotenuse.
It's working. Fine.
Hi, if you don't need this, we can go right to the homework. Have a test on it tomorrow, because you seem to know it. You're confident, right? Okay, then let's pay attention.
I am.
Thank you. Hypotenuse. Actually, who thinks I know what the plural of hypotenuse is? Nope, it's not Latin. It's one of the only math words that is... Probably. It's from the Egyptian. I don't know how to pluralize Egyptian.
If you don't know, you ask us.
No, I don't know.
You don't know how to
I just want to see if you guys would assume it was Latin. And most of you guys did, which is a safe assumption with a lot of math words. Hypotenuse actually comes from the Egyptian word that means rope stretcher. Because the ancient Egyptians had figured out...
Oh, okay, I got it.
Hypo.
What had
Anyway.
to figure out?
Well, they had figured out that if you had... Do you guys remember Pythagorean triples?
Yeah.
Like if you have 3, 4, and 5, it works with the Pythagorean theorem, because you get 9 plus 16 equals 25.
Yeah.
Well, the Egyptians had figured out if you had a rope that was 3 units long on one side, if you had a rope that went 3 units long, then 4 units long, then 5 units long, and you tied it off and held it in the shape of a triangle, they knew you would have a 90-degree angle. This was an early protractor. So they took this rope, marked off 3 feet, then marked off 4 feet, then marked off 5 feet, tied the ends, and held it at the 3-foot, 4-foot, and 5-foot mark. It made a triangle, and then they would hold it up to a building to see if they were building straight. Because they couldn't actually build it like protractors.
The pyramid sideways.
And they didn't have levels. Pardon?
The pyramid sideways. Do it again.
If the pyramid sideways, do it again, basically, yeah. Now, the other 2 sides here are going to be described in terms of theta here. This side is opposite of theta. Okay? And this side is adjacent to theta.
So cosine.
Okay? So, if this angle, this side's described as its opposite, this side down here is described as its adjacent. What does adjacent mean?
Next to.
Next to.
No, it doesn't mean next to.
Means next to, touching, right up against. Now, the sine of an angle is going to be the ratio between the length of the opposite side and the length of the hypotenuse. Now, hypotenuse is defined as always being the longest side of a triangle. So that means that this number will always be less than 1. Because you're going to put this shorter leg divided by this longer leg. So, if at any reason you're figuring out the sine of an angle and you get a number bigger than 1, you have made a mistake somewhere. Can't happen. There is another measure called the cosine, which is abbreviated COS. And the cosine of theta, does anyone remember what that is? Adjacent over hypotenuse. What's the most common mnemonic? SOHCAHTOA. SOHCAH. Wait a second for the TOA part.
Unpleasant flashbacks.
Right. Now, once again,
Horrible person.
right. Once again, the hypotenuse is always the longest side of the triangle. Okay? So the cosine also has to be less than 1. I'm going to write this as 0 is less than the sine of an angle is less than 1. And 0 is less than the cosine of an angle is less than 1. Can't help it.
Hey, sorry to interrupt. Can I borrow your conic thing? Do you have that?
Yes. Cody, can you hand me that from the... Sure. All right. Okay. Now, the last one is the... Well, no, not the last one. I'm actually going to talk about 3 more of these today. The tangent
Why?
is abbreviated as tan theta, and this one is opposite over adjacent. Okay? Opposite over adjacent. These side lengths can actually be anything you can imagine. Okay? What can happen is this hypotenuse can be angled way up high, so you can have a really tiny adjacent and a really big opposite. This hypotenuse can be angled way down low, and you can have a really tiny, tiny opposite and a huge adjacent. What that means is that the tangent can actually go from 0 to infinity, not including infinity. Tangent can be any number. So if you get a tangent of 512, that's okay, that's possible. If you get a sine or a cosine bigger than 1, you have made a mistake somewhere. Now you're going to learn 3 new words. Who am I? Right. Okay, new ones. For reasons that are not going to become clear for a while and some people never agree with, there are 3 other trigonometric ratios, and they relate to these. I mean, if you think about this, this pretty much covers it. You've got an opposite, an adjacent, and a hypotenuse. What else is there?
Yes, why would we more?
Well, what they do is they made reciprocal ratios. So there's the cosecant, okay, which is abbreviated CSC of theta. Now, we're all still talking just about this angle. We haven't even talked about this angle up here yet. Not a big switch just to go to that angle, but we'll talk about that. The cosecant of theta is the reciprocal of the sine. Now, if the sine is opposite over hypotenuse, what do you think the cosecant is?
And then 1 over...
Well, you can make it 1 over that. What can you do when you're making a reciprocal of a fraction? What can you do to the fraction?
Oh, negative.
Flip it upside down.
Flip it upside down.
So it would be hypotenuse over adjacent.
Hypotenuse over adjacent. Now, some people were just thinking about negative numbers there. Reciprocal don't have anything to do with negative numbers unless you're dealing with negative exponents. No, not hypotenuse over adjacent. Thank you, Amy. Yes, right idea, Kara. But it's hypotenuse over opposite. Okay? The secant is abbreviated SEC theta. That's 1 over the cosine of theta. And now, Kara, flip the cosine, and what do you get here? You just said it a second ago.
Hypotenuse over adjacent.
Hypotenuse over adjacent. Very good. And then we have the cotangent. There is a reason